Okay, so this is a video to explain assignment 4F, question 3. Post-class assignment 4F, question 3. Okay, so here we've got our car, we've got a rope strung between our car and a tree trunk, and we're pushing in the center of the rope here. And we want to know how much force we have to push on the center of the rope to get a 13,000 Newton force on the car. So I'm going to draw this down here in a simpler way. Free body diagram without so much clutter. We've got our tension force here, our tension force here, and our perpendicular component. So we want to consider at this point where we're pushing, what are all of the forces? So we've got our perpendicular force here. I'm going to draw it this way so that our tail is at that point. Okay. Force perpendicular. And then the tension force here, that's the same tension as in the rope. Let me get a different color. I've got my force perpendicular. It's the same tension as in the rope, but at this point, we can imagine it pushing back where we're pushing. So we've got tension force here in both. Now, if I draw just one of my T's, one of my tension forces, it's got two components. So if this is my angle theta, that means this is my angle theta here. And this y component of that force is going to be T sine theta. And this x component of that force is going to be T cos theta. All right. So if we're at equilibrium, all these forces are going to sum to 0. We can see that the x components of this tension force pulling up and to the left and the one pulling up and to the right cancel each other out. And so we want to think just about the y components. And so we've got that F perpendicular plus 2t sine theta equals 0. Okay. We have 2t sine theta again because we've got two of these, right? We've got this one from this force on the left, and then we've got one of the same magnitude from this force on the right. Okay. So the magnitude of our perpendicular force is going to be negative 2t sine theta, and we just, again, care about the magnitude of it, so I'm going to just take the absolute value here. So the absolute value of my perpendicular force is 2t sine theta. And now I can plug in numbers here. So 2 times 13,000 newtons times sine of 1.1 degrees is going to give me 499 newtons. Okay, so this is a pretty clever way to reduce the force we need to apply in order to get the car out of the mud. Okay. All right. And then the second part of my equation says second part of my question says if I apply the same force from part A, so if F perpendicular is 499 newtons, and then that angle increases to 7 degrees, what is the tension? So now this equation is still true, but now this time I want to solve for my tension T. So that tension is F perpendicular over 2 sine theta, which is now 499 newtons over 2 times sine of 7 degrees, which is 2,050 newtons. So you can see here that that angle matters quite a lot, right? We go from an angle of 1 degree to an angle of 7 degrees, and now our force has fallen very significantly. All right, that's it.